Hey everybody, today's lesson is on food chains and food webs. So a food chain is a diagram that shows how energy flows through an ecosystem. Here at the bottom of this food chain, we always have our producers, which is always a type of autotroph. Right? An autotroph, if you remember, is an organism that can make its own food, usually through the process of photosynthesis. Occasionally, like if it's at the bottom of the ocean, it's this process called chemosynthesis where they're using chemicals from the earth instead of sunlight to make food. Now, that energy from this producer, in this case it's this little plant, gets passed on to the consumer, which is always a type of heterotroph. A heterotroph, you remember, is an organism that can't make its own food through photosynthesis or chemosynthesis and must consume other organisms to get the energy they need to survive. Now, eventually, the energy moves up the food chain, passing from consumer to consumer to consumer. When any of these consumers dies, the energy is broken down by a decomposer, which again is a heterotroph. This is usually a type of fungus or bacteria, but they obtain energy by breaking down dead or decaying matter. Now, similar to a food chain, another diagram is called an ecological pyramid. And in this diagram, it shows how the energy changes as you move up the food chain. Now, each step in a food chain or an ecological pyramid is called a trophic level. So if we look at the diagram below, here we have an ecological pyramid that has 3 trophic levels. We have one level with trees, a second level with giraffes, and then the top level with lions. Now, whatever's at the top is known as your apex predator. And given the choice, everybody thinks that they want to be the lion. Right? Everybody wants to be at the top of the food chain, at the top of this pyramid. But really, this spot is the hardest to survive at. The reason is because every time you move up a step in the food chain or food pyramid, only 10% of the amount of energy that organism has gets transferred up. Right? So if you look at all the trees in an African savanna, they have about 9,000 kilocalories of energy, right, which allows their population to grow to huge numbers, 500,000. However, as the energy gets transferred up to the next trophic level, only 900 calories goes up, right, which means the giraffe population is much smaller. Right? That herd of giraffes in the savannah is only 22,000 giraffes. And then by the time you get up to the top step of lions, we only have about 90 kilocalories of energy flowing upwards, which means that the lion population can only be about 200. The problem is that if the lion population got much bigger than 200, say 250, there wouldn't be enough energy for all those lions to survive, and they would starve to death. In fact, being at the top is hard because whatever the top predator is, almost always like 3/4 of them, 75% of like great white sharks and polar bears and tigers and lions, right? They die of starvation. And if you think about the animals that are always on the endangered species list, it's always these top level predators, because they have so little energy to live off. And if anything happens to these organisms below them, they suffer. The last diagram I need to talk to you guys about is a food web. And a food web is nothing more than a bunch of tangled up food chains that show how energy flows through an entire ecosystem. Now, most students already know how to read a food web and very, very comfortable with it. But let me give you an example anyway. So over here we have a question that says, what will happen to the killer whales if the krill disappear from the ecosystem? So killer whales are an apex predator, so they're right here at the top. The krill are primary consumer, so they're towards the bottom here. Now if you look carefully, you'll see that there's no direct line connecting krill to the killer whales. So you might think, if the killer whales die, if the krill die, nothing will happen to the killer whales. But that's wrong. Right? You see, everything above krill kind of eats the krill, right? So, for example, if the krill die out, well, the blue whales eat the krill, so now the blue whales disappear. And if the blue whales die out, there is one less food source for the killer whale. So the killer whale will now decrease in number, right? So what we'll see is that if the krill disappeared from the ecosystem, the killer whale population will also decrease. Alright guys, that's it for today. Thank you.